time. Start recording. There we go. Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We are in the process now of working out how we're going to do sort of our final entity world building kind of stuff. And yesterday we ended with... I guess what we did is we sort of ended with the concept of the hero being able to stand on something, and that something could move, right? And so what we want to do now is sort of start finishing up that process, because I had talked about how I wanted the game to always have the understanding that any individual entity is who is supposed to be walking or moving or hopping on the ground has to occupy points on the ground very specifically. So it's, you know, it's an action game, and you move the head of the character around fairly freely, but where the character is standing and where everyone else is standing, it's almost like chess in a way where you are occupying a particular square and only one thing can occupy that square. And so what has to happen is we have to have a solid understanding of where every entity is in terms of what square they're on. And so we sort of did the first part about that yesterday, but we haven't done the second part, and so that's what I'm going to look at if I can stop my yogurt from falling over. All right. So let me just show you what that is. Also, I guess I should always remind you, today's day 284, so if you want to follow along at home, day 283 is the source code. So here we go. So here's where we left off. And as you can see, we still kind of have, you know, our basic hopping is still working exactly the way that it used to. And with the exception of our rendering, that's all kind of okay so far. But what we did yesterday is we just wanted to prove, okay, I can kind of go down and ride this thing. Unfortunately, we have this problem, and this was the thing that I was talking about we need to finish up, is that currently we still don't really, in our entity code, process the concept that the hero is standing on a particular thing. We always use the point that is closest to his head, the entity his head, as the thing we should jump to. And so, as you might expect, what ends up happening as the hero gets into a situation where their head is between 2 points, it can sort of wig out. The body will keep jumping between two different things, right? And so we want to, obviously we don't ever want that to happen. And now that we have this more sort of specific concept of where the hero actually is anyway, and the concept of this traversables and all that sort of stuff, I want to basically fix all of that. How is that even possible? That looks like a bug. A pretty good bug, though. You see that? I like that. That's probably a bug in our packing, but I want it to happen again. How do I make it happen again? You can see that it kind of wigs out there. It jumps, right? And I feel like there's a bug in the packing of that guy or something like that that we should look at, but that's, I guess, a separate issue. But anyway, so first things first, let's actually go in and finish the code that we were working on before, and then we can look at sort of the way that these things are packed and make sure we don't have any bugs there. We can put in some assertions for packing where we can pack and unpack something and make sure that it's not messed up, right? Anyway, so how do we do that? How do we get out of that sort of hacky place of not really having the person understand where they're standing? Well, we already named this thing standing on, and so really all we need to do is start to take our entity controlling code more seriously and actually treat it as such, right? So the standing on, where are you? There we go. So the standing on, when we come through here, you can kind of see that it's super janky in that what ends up happening is the only thing that we use to determine whether or not we're going to hop is the distance that the body is from the head. That's it. And so we don't really... wait, is that actually true? That's like not even what that thing means, actually. The body delta is the closest P on 70. So it's not even that. That's not even what that means. It's the distance to that point, to whatever the point is that we want to go to. So we need to, this needs to not be what's happening anymore, right? That we need to not make this be the code. So let's think through a little bit more how we want this to happen, right? And if we go ahead, you know, I can sort of show you as well what happens if I was just to sort of if zero this out, right? If I was to say this is not a thing, and instead all I'm going to do is just do found. Well, in fact, you know what I can do? The easiest way to do it is just to say found equals false. So assume that it never finds a new point to stand on, right? So essentially what happens is if I never textures, if I never do anything else, right? You can see what happens here. And basically we just stretch out the hero infinitely far, and the hero's head will come to rest above whatever point they're, most closely aligned with, right? And that's not, like I said, not particularly useful for us, and it's not what we actually want. So the first thing we should probably do is make the head be a little bit more specific in how it operates, right? And there's two things that I want to do here. One is that I'd like to keep the Z height of the head strictly controlled so that if it's on the body, it's always in a very specific place, right? In other words, it doesn't float all around in some kind of random way, right? So there's that. And then the other thing that I want to do is if you can't jump, so let's say that this was actually the correct thing that should happen. The hero's body is meant to stay on that square, and like maybe there's something in the way here, or there's something occupying the square so it couldn't go there. If there's something in the way, then what I want to have happen is when the hero's head hits the halfway point, I don't want it to go any further, right? So I basically want the hero's head to stop, like right there, and not be able to go. So even if I'm holding down that button, instead of it just continuing on like this into ridiculousness, I don't ever want to allow that situation to occur, if that makes sense. So I want to stop. So that's the stuff that we need to work on for the head. And then what we need to work on is when the head does get to that halfway point, we want to trigger the hopping event. So we can say, okay, if we can get access to that point, then allow the hop to occur and the head can continue going, right? So that's what we want. Again, it's a pretty tricky control scheme. It's, a lot of times it's way simpler the way a player controller works, where you just kind of move it in whatever direction the person pushes and you're done with it. In this case, we have a much more complicated scenario, so this code is going to be a lot more complicated. Again, that's just par for the course, not a problem. You just gotta be willing to write the hard code when the hard code comes up. So, let's start by thinking about how we're doing this. First of all, what we might want to do is just have the body maybe be something where its hopping is a little more predictable. So maybe we'll do something like say, okay, let's pretend we're not going to do any of this stuff, right? And let's I don't know what's going on with facing direction here. We just copy that in. I'm gonna go ahead and pull that out here as well. Okay. So I've got the facing direction and I've got the DP here initialized. I've got the entity P set to whatever the thing is that we were standing on when we're in the planted mode, so that's fine. And then we've kind of got our other stuff here. The DDT Bob, we always, I guess, edit during this loop. So I'm going to put that a little closer to here. There we go. And the floor displace is always set based on the head delta, which is also fine. So I'm going to recompile this here. So really what I want to do now is just kind of replace this logic that we were using, which is about what we're supposed to do, right? Whether we're supposed to do the hop or not, and what's supposed to happen, right? So what I want to do there is I'd like to do something where we sort of say, okay, if we're planted, I don't want to start hopping unless somebody has told us to start hopping, right? And maybe that hopping is some kind of, I don't know, it's some kind of a request. Maybe that hopping is actually triggered by the head, for example. So maybe this in and of itself is actually going to be moved out, right? Let's say we do something like this. So we come up here to the head, and we say that this is going to be something that happens on the head side of things, right? And I don't know exactly what will happen with it yet, but we're going to put it out there. And similarly, I guess we could also copy all this code as well. I don't know that we're going to use it, but we could try. So now here we go with the code that we had before. And if you look, it's really just the floor displace, I think, that uses the head anymore. Nothing else uses the head, really. So I think what we could do is also move this head stuff, move that down. Because now all of these things, the rest of how the body hops and stuff, all of that stuff is now something that we could allow to have happen separately, right? Meaning the hopping is sort of isolated from whether there was a head that was controlling it. And the reason that I care about this is that we're eventually going to want hopping creatures, potentially, and we would want to reuse this code, right? Because there's no reason why we would have to change the code in that case. Oops. All right, so in movement mode planted, so again, this can come down here, and this can be something that just says, hey. Is all of this code DT Bob? So all of this code is not based on the head either, right? And this is just if we're in the planted mode. So there we go. So now we've sort of taken the head out of that. And I guess also, you know, since the head distance is probably something we'll be computing more elsewhere, I guess we could also move even this part. We could move this up to the head controller so that we never, right? I mean, because I guess there's really no reason not to do that as well. So the head controller can trivially just reach in there and do that, right? Okay. So now what should happen in theory is no matter what I do with the head, the body should just stay there and not do anything, right? And that is exactly what happens. Okay. So now let's go ahead and expand up this code and start to work on the head controller. So on the head controller, some empty space there. Are we going to get new indentation stuff anytime soon, Alan? Is indentation on the menu? I don't really know what's going on with 4Coder at the moment. Maybe that's not a current thing. But I thought I saw Alan on here earlier. Let's see. So in through this code, what we want to do here is say, all right, let's re-enable the parts that have nothing to do with the movement first, because those are the ones that we already know we kind of want, right? So what we actually want to do through here is, rather than talking about head and entity and that sort of stuff, I think what I'd rather do is have head and body be specific, even and rather that way when we move code between the two, it won't change, right? So I don't know if we ever look at the body in here. I thought we did, but I'm not sure. It looks like we actually don't. I thought we did, but maybe we don't anymore. I don't know. But either way, when we come in here to do the controlling for the hero head, what I want to do is I want to go ahead and make it so that we track the head and the body like so. Right. And then we can just say, well, if there's a body, we'll do body things. If there isn't, there isn't. Right. And so this code was not using the body before. This code is using the body before. So now I'll just go ahead and say if the body exists, then through here, what I actually want to do is replace the word entity everywhere with the word body. Oops. Because that's what was previously the entity that was being talked about there, but now isn't. And so what we can do here is say, well, all right, all of this stuff that was previously before requiring the body now exists in here. And again, anywhere that it was talking about entity, I will just go ahead and force it to talk about the, oops, I don't know why I can't spell entity for some reason. So there we go. Body is not a member of entity. Wait, what? It's not? Is it head? What is it? Yeah, it is. Never mind. And so, yeah. So the only thing that we have left that is now something that's a little bit tricky is the bounciness. When we're in the movement mode planted, we were trying to make our bounciness be proportional to how far away the head was, right? And so I don't know to what degree we want to split the code between these two, right? But you see I'm trying to figure out like exactly how much should live in one versus how much should live in the other. And a lot of that just has to do with how they would separate out. To whether or not they are both operating separately versus operating together. And the question here is just that, well, this is really something the DDT Bob seems like it should be kind of something that's more related to the body, but I guess it really only requires T head distance, and T head distance was not a particularly complicated thing to compute, right? It's just the difference between these two. It's just this value here. And so I think we could probably safely have left it down below, so maybe we will. Oops. Because if I look at this, it's only head delta that gets used separately. So what I could do is say, all right, here's the hero body stuff. In here, we could just say, oops, that we want to set the DDT Bob if there is a head. Then compute the head delta. Right? Now, in here, we want to keep the same naming scheme. So I think I want to, like I said, I want to go with something like this where no matter which controller I'm in, I can always talk about the head and the body and just say if I have a head, if I have a body, whatever. So I'm just going to go ahead and reverse what's happening here, like so. And then I'm going to go ahead and run. All right. So now we can see essentially what's happening here is we're just getting that sort of stretching out action is happening, but we haven't re-enabled the rest of the code, right? So let's go ahead and go back in and try to make that happen. Yeah, so let's see how this stuff works. When we have a body, we're trying to find the closest traversable. We're seeing if we found it. If we were, we would switch the mode. Oh. So interestingly enough, that should have started... We should have been able to initiate a hop, but it didn't initiate a hop. So I think that I messed something up, because oh, I see what it is. There we go. Still not right. Not correct. So let's see what we've got here. This is just setting DDT bob, which is when there's the head, it wanted to do that sort of head distance bob down, so that's fine. And with hopping here, this should all be independent of the head. So that all looks correct as well. And the DDT bob update still happens in here. All of that seems reasonable. So I think we just have to make sure that I didn't mess up something in this code. When we snap the head and the body, we come down through here. We are updating the head's sort of idea of where it is. And then we come in and say, if we've got a body, which we know is should be true, right? Maybe it's not. I should double check, but I'm pretty sure it should be. I guess I should double check to see that we are not hopping, or I should say planted. Because otherwise I'd keep sort of setting it back, right? So if we look here, we can say that the head delta is based on these things, and I guess I suppose those things actually now can stay down in here. As you can see, it's kind of a little tricky, like to figure out exactly where I want everything, because each thing is going to kind of is going to want to be potentially split apart. But yeah, I only want to do the move. I only want to update to a hop if I'm standing, obviously. So that has to be changed. This copy in works fine, as does all the rest of this, I think. So we should be good to go. So we're almost there, but our slant code now that actually shears us is not always operating properly. Which that code, right, is, I put it in the planting code here, but I guess that's not what we should do. I guess that we wanted to have happen always, which makes sense because you want it to be continuous, right? I want to be able to specify the floor displace and the y-axis and stuff continuously as we go. So that should probably be stuck outward, right? So I'm going to go ahead and put this up here. I'm going to say that head delta equals nothing. I'm going to say if we have a head, we will compute the head delta. And then this code can update based on that. Always, because why not? And so that's back to the way we were doing it now, except now the choice to hop is being made by the head, right? The head is basically telling the body you should hop, okay? So now what I'm going to do is I'm going to go up back to the code for the head, and I want to now kind of collapse these together, right? Because we're doing double get closest traversable on the head right now, and so I just kind of want to make that into one code path. So I'm trying to think of how this should work exactly. I guess I still want to start off doing the same thing that I was doing, which is to say that I guess I don't really need the concept of the closest p, because it wouldn't happen outside this anymore. It would only happen inside. So when I come through here and say get closest traversable, what I want to do is I want to, entity is head, obviously. I still want to get that and say, is there a new closest traversable to the one that to a different one that I was on before? And what I want to do now is I want to actually compare those. So instead of before where I was just like, oh, where's the point relative to my body or stuff like that, I want to say, is the closest traversable the one the body is standing on or not, right? And furthermore, I suppose this code should probably be, well, I'm gonna do it in two sections. I'm not gonna try to merge them just yet. So what I want to do is say, all right, if there's a body, then I might need to do something. If it's not, then I'm headless. I'm just a floating head, right? So if there's a body attached to me, what I want to do is say, well, is the traversable that I found, is that traversable? And I'll do a test like r equal. If this traversable is equal to the one that the body is standing on, then I don't really have anything to do, because the traversable that the head would want to be on top of and the one that the body's on top of are the same. If they're not the same, that's when I actually start to care, right? So if they're not the same, then I want to start to do this stuff, right? I want to do this. I want to basically say, all right, I don't really know that I care about this. I just want to say straight up, whatever the body delta is, none of that stuff, none of this matters anymore. What I want to say is if they're different, right? If the two of them are different, don't even care about any of this either. I'm just saying straight up, if I'm not standing on the one that my head's on top of, then I want to do the movement, right? I want to move to the traversable I found in the hopping mode, right? And furthermore, I can probably set this out, which is to say that if the body is not in the movement mode, if the body is not planted, if it's already in the process of hopping, then there's not much I can do, right? So leave it that way. Okay. We no longer need to do this. We can let that code flow through, and it should work actually quite the same as it was working before. And we don't need to do any of this anymore, or at least I don't suppose we should. We can still sort of do any updating we wanted here. Oops. So we'll leave that as is. So now we just need a couple helper functions. What's going on here? Closest P. So that just, I guess we do want to copy that one piece of code that was getting the actual location of the traversable. I'm going to move this over here so I'm not behind my head so much. I can't see the code. Do we never get that? I guess we don't. I don't know. Oops. So if we go here to the code where we have the traversable, I guess the closest P is now just whatever that traversable P is, right? So in here where we were using closest P, I can just do closest P equals traversable P, right? Is equal now is just a thing that we need to do in the entity code. When we have these traversable references, all we need to do there is just say like, okay, these will be equal if they are the same entity in the same index. Very, very straightforward, right? So the result equals, you know, entity pointer, oops, a entity pointer equals b entity pointer, and a entity index equals b entity index, and a entity, sorry, a index equals b index. Now, technically, I only have to compare the entity index or the entity pointer because they're actually a union. So I suppose what I'll do is I'll just compare the one that would ever be larger of the two, I suppose. But what I really want to do there is just say compare the whole size, the whole thing. And I'm not really sure of the best way to do that. So I'm hoping the compiler would just figure it out, you know. But you know, if it doesn't, it doesn't. It's not going to be a big cost or anything like that. So let's see. Entity ID does not. Oh, great. Sorry. I believe we have to do value there. Okay. P is not a. It's not. I thought it was. I guess I have to call get sim space. Get close to traversal. I guess I have to call get sim space. Okay. So now we should be doing the same stuff we were doing before, but semantically, right? And in theory, nothing should change, and it doesn't look like it did, right? So, because we haven't put in any logic other than closest point. So closest point will still be exactly what happens always. So yeah. So now what we need to do is actually put in some logic for whether or not you should be hopping based on how far you're pushing the head away from the body, right? Okay. So in here, right, what I want to do is, I think what I want to do now is actually start going back towards the sort of the head delta concept, which is to say that when we get the closest traversable to the head, I guess I actually want it to be the closest traversable cast downward would be the first thing. Like, I want it to actually be relative to where the head is. The thing that I'm having trouble understanding, right, is the head should be at the same point as the body. So I guess I'll be honest, I don't really understand why it's ever, this code I feel like shouldn't be picking. I feel like this code should not be choosing to move, to be honest with you. Because I feel like the head is not, it is in the same place as the body. So when I call, right, because remember the head is a weird bitmap right now, and so the ground point for the head is still in the same place, I think. I mean, I could double check that, but I'm pretty sure. So technically these two should be calling the same function, right? I mean, not calling the same function, but they should always be picking the same point. And I don't know why we're ever getting that choice to jump to something else. That's real confusing to me. Furthermore, it's like kind of confusing what's happening too with the, yeah, I think, so I'm going to say that that's not an artifact of how we're choosing it. I'm going to say that's just a bug. And so I'm going to investigate that like a bug. Because I don't think that should be happening. So the first thing I want to do is I want to know where these entities actually are. I want to know where their actual ground P is, right? And so I might draw it, but I might also, the first thing I might do is actually just debug value it, right? So in hero head, I want to do debug value. And I want to do that in where is it? Hero body as well. So yeah, let's see. So it's behaving roughly like I would expect so far, which is to say the bottom one is obviously the body, and you can see that it moves when it hops, and it comes to rest on the correct position. The top one is a spring, so it like relaxes back to that exact position eventually. So now let's hop on here and see what's going on. I mean, those points are just real close, right? I mean, they're really just not that different. So why is get closest traversable picking something different there? I don't know. So let's take a look, because that's important. I think that's a bug, maybe in get closest traversable, or at least in the way I'm conceptualizing how this thing's working. And so I don't want to go any further till we have that sorted, because that's just obviously bad. So yeah. All right. So let's go over to Handmade sim region, and let's look at get closest traversable. So here is get closest traversable. Here's how it works. We loop through the entities, and we loop through their volumes. We call get sim space traversable. We look to see, I don't know, we still call it head to point, which is good. Let's maybe call that 2 point. And then let's take a look at what's going on here. So there's 2 point. First thing I'm going to do is we sort of did this thing for fussing with the z. Let's take that out of the equation temporarily, because if we still get the bug with that, then at least then we don't have to think about whether that was involved, right? Good. So it has nothing to do with our crazy like preferential treatment. We're just getting something unusual happening. So looking at this, and we get the sim space traversables, we look at that 2 point pp minus from p, we take a look at the length squared, we look to see if that length squared is better. We then snap the entity pointer and the index, and we update the closest distance squared to be whatever it is that we expect it to be, and that makes good sense, right? So that looks pretty reasonable. So we're probably going to have to step through that and see what's going on. Let me do one other thing. What I would like to do as well is in world mode here, where we've got this entity simming happening. When we call get closest traversable to the head, let's just actually call it on the body instead and see what happens there. So now we're not even using the head point, so the divergence between the head point and the body point is not even relevant anymore, right? Oh, right. I can't do that till I actually get over there, can I? No matter. Not a problem. I'll just use live code reloading, which is so awesome. All right, so let's go ahead and change this to body. Hop on there, recompile. Oh man, he hopped off before I could do it. There we go. All right, so maybe I use loop live code editing to do this. Loop. There we go. So now I'm going to change this to body. So now the dude can't move. And now I'm going to restore the loop point so that we're on there. Whoa! Yeah, we have a crazy bug. It looks like the Z values for our entities are not getting packed properly. I'm kind of glad we've got this caught in the loop. Now we can actually debug it too. Right? It looks like what's happening is that point is getting levered up somehow into a different region. Like the Z packing is not working. You know what I'm saying? Let me take a look at what's going on there. Because maybe that's actually both bugs. So here's nsim. nsim has this chunk delta thing, and what happens with the chunk delta is we basically add it in before we pack our entity down. I'm not sure that's a good place for that, for obvious reasons, because we actually should be doing that in the pack code, right? I mean, that's the sort of thing that should be done in the pack code. But let me find the bug first before I go making changes. So in here you can see we take the region world chunk P and the region origin. This is the chunk the entity is being stored into. This is the origin of the sim region. And that delta, right, is the one that we want to remove. If we're subtracting that chunk delta off, and let's also go kind of back here and just double check. So in here where we update the camera, that shouldn't really matter because the camera doesn't change that chunk delta anywhere, right? So the fact that the camera gets updated here isn't really an issue and doesn't really matter to us. So then we come back in here and we do our entity plus chunk delta, and then we pack the entity into the world. And that seems fine. So if I come over, and I wanted to point out one other thing. So it's also not just the hero who is moving, it's actually the point they're standing on. So it's actually that entity that's getting packed wrong to begin with, or getting moved incorrectly. So we don't even have to look at the standing on part of the hero. So we can take the hero out of the situation entirely, which is nice. That makes sense. Okay, so when this is being packed, I want to go into the world code and take a look at pack entity into chunk. So here's pack entity into chunk, and essentially what we do here is we just pack the references, but we leave the rest of the data untouched. I guess I don't really know. We pass the world position at, and we're passing entity P. And entity P and chunk P are the same thing in this case, right? This is the map into chunk space. It's basically just asking which chunk the entity should be stored in, right? So we're saying, hey, if this is the chunk around which you're stored currently, and here is the entity, give me that delta. I'm sorry, not give me that delta. Tell me where that would actually be. Now, how is that code even working? Because we haven't looked at that in a while either. So that's taking an offset that's dividing by the chunk dim, and it's taking a look at the tile and the tile relative portions. Yeah, so really, I mean, really, this all seems, at this point, quite a bit overblown as well. Because really all we need here is an F mod, right? We're just asking how many tiles over in X this thing went, how many tiles in Y, and how many tiles in Z, right? So this is just 3 F mods. So it may be time to start cleaning this up a little bit as well. Let's think about this. So when we recanonicalize coordinates here, right, we kind of did this, and it's a bit sloppy, right? The way that this works is we're taking whatever the world position this base pose was, right? And when we do map into chunk space, by the way, I don't even know like how many people even care about that. Let's go figure out who's using this, right? So the simulation uses it. And I'm assuming that this is just to, yeah, that's just to figure out where the bounds are. We use it in the packing case we were talking about. And we use it similarly to move the camera, right? And then the only other time we use it is when we're building the world. So very few people ever care about this. And really, yeah, the chunk position from tile position really just uses it because it needs this additional offset thing, right? Yeah. So I feel like we should clean this code up. That's what I think we should do right now. So what we really need when we're doing, when that's not where I wanted to be, what we really need when we're doing this recanonicalize, and I assume that recanonicalize is only used here as well, right? Yeah. All we're really doing here is saying, well, whatever this offset was, excuse me, whatever this offset was, we want to figure out how far that offset would move us from the base pose, right? And we want to compute a combined offset, right? So we have like a total offset, and that's whatever the base pose offset is, plus our offset, right? However much that actually is. Now in the future, I think world position, I think we're going to get rid of offset from that, and it's just going to be the 3 indices, and they're only going to be stored in the chunk. So I think that's going away eventually anyway. So like I said, we probably won't need this plus offset, so it'll just be the total offset. Will just be equal to this, right? So now if I want to know how many of these, how many steps I'm going to take, right? If I want to know like what my d chunk x is, because this is what I want to know, right? Then all I really need to do here is some kind of a modulus. I just need to say however far I was moving, I guess I shouldn't say modulus. Modulus is the wrong term. I just want the integer divide, right? I want the divide and floor, right? And you can see that we're doing that here essentially, but we're sort of doing it in a I think what's sort of a somewhat busted way. Anyway, saying modulus was not quite correct. So what I want to do here is I want to say, I just need to know how far this would have moved me from my current base pose, right? Because I'm at wherever that is. How many tile lengths would I go, right? And I can figure this out. Let me see here. What I can do here is I can figure out this tile delta. I should be able to say, well, whatever the delta is, right? If I've gone half the distance, right, I get one of them. And then for every one after that, I get another one, right? So like the first 0.5 gets me to the next tile. And then after that, I have to go one each time, right? So what I kind of want to do is just add 0.5 and then divide, right? If I just add 0.5 to it first, so that if it was 0.5, it would have rounded up to 1, that's all I should really need to do. And then I can just use a standard truncation from there, right? I just can use truncate towards 0. And that should be fine. So I guess that's why we were using round before. So now that I think about it, this code, I was thinking that it was going to be easier, but now I think this code is actually not too bad, right? It's using round because whatever the divide was, it's going to round to one way or the other. So that seems okay. And then it's adding the however many that was to wherever the tile is. Then it's taking whatever the relative amount was and subtracting off however much it actually did go, right? This should be a little clearer here that this is a floating point. That's a floating point multiplication, right? Using whatever the chunk dimension is. And then, well, I don't know, I guess we're asserting just to double check, if that makes sense. So that actually does seem, now that I go back over it, that actually does seem reasonable. It's not as weird as I thought it was at first. But I still want to make sure that I don't have anything weird going on here. And that seems all right. So the thing that was throwing me off is this is the plus equals here, right? It's like, oh, okay, I see. So the reason we're doing the delta in here, which is why we weren't talking about deltas out here. So that's okay. And so similarly, I guess we should double check our subtract here. So our subtract is looking to see what the difference in tiles is between the two things. And then it's multiplying that by however big the tiles are, which seems reasonable. And then it's looking at the A offset minus the B offset, which is the delta between offsets. So that also seems right. So that seems pretty good. Do we use this function anywhere? Looks like no. All right. So yeah, I guess we're gonna have to step through this, somehow figure out what else. I don't see, just you know, sort of looking vaguely at it, I don't see what the problem is offhand, unless I'm missing something. I feel like this is probably working okay. Famous last words. Tile relative divided by chunk dim is going to round. Does that work in the negative direction correctly? I think it should, right? Because chunk dim's positive, tile rel the tile relative motion would be negative. You would get a negative number, which would be a negative offset after the round, which is what you want. You add that in, you move that direction, the tile relative amount, again, you just subtract off, and that'll work negatively correctly. So that seems right. We're passing the right dimensions for everything. And yeah. Yeah. I don't see anything particularly wonky. So that's it. Yeah. I think that seems reasonable, if that makes sense. All right, so let's think about what I can use for a debugging strategy here, because if it's not a mapping problem, I'm not sure what exactly it is. And so, yeah, I feel like I can probably, you know, it's moving by that delta. So it has to be something with getting the wrong chunk Z, right? It's like levering onto the wrong chunk Z or something, it would seem. At least that would be my assumption. So yeah, so assuming that it's not that, I suppose when we actually look at the map into chunk space, I'm wondering if there's maybe something, if it picks the, well, let's take a look. So I'm going to go into sim region, and I'm trying to think if there's a, like, since that's a hard case to find, I'm trying to think if there's any way I can figure out some sort of a more specific way of checking whether something discontinuously moves from one frame to the next in a way that we don't expect. But it's kind of a hard thing to figure out how we would detect that case. You know what I mean? So in here, when we unpack the entity, we take the chunk delta by saying wherever the origin of the sim region is, we want to move it out to whatever the chunk position is. The chunk position is just at the XYZ of that chunk, right? And that seems totally what we would expect. We take whatever the p-value is that comes in and we offset it by that chunk delta, right? So that's fine. What I don't know, why is add entity taking the chunk delta? So it adds it there. So the sim space p is, this is just used as a check, but then add entity does the chunk delta addition. Yes. All right, that seems reasonable as well. And then in the msim, same thing. The chunk delta is inverted and it's added. So it should cancel out, assuming the chunk is the same. If the chunk isn't the same, well, that's okay. That's still, that mapping is still supposed to work. So let's try this. Let's try this. So when we call pack entity into world, I'm going to say that pack entity into world, I'm going to try to verify what ends up happening. So pack entity into world here, we call get world chunk, right? And then we do the packing. What I want to know is, after I do this packing, would I get the same thing out again after like doing the test? So basically, like, I want to test P, and I want to say, well, if I were to call map into chunk space, or I guess not map into chunk space, I should say, if I do the reverse mapping after the pack. So if I say, well, exactly what I was doing here, and I say, okay, here's the chunk delta. I want to subtract whatever the chunk position is, and I know what that is, right? It's the entity P. And that doesn't include any offset, right? It's just the X, Y, Z. No, it doesn't. No, it definitely does not. You see the bug? Or at least, do you see a bug? I see a bug. Someone was being sloppy. And that someone was me. This is not the chunk P, right? Oh, okay, no, I guess I wasn't sloppy. I was gonna say, this is not the chunk P. The chunk P has to have the offset removed from it. But it does have the offset removed from it. All right, never mind, never mind. I was about to have to hold up the owl of shame. I probably still will have to hold up the owl of shame, but in this case, no shame yet. I did zero it out. Okay, so the chunk delta is the difference between the chunk P and the sim origin, and then the test P is just whatever the entity's P value is now, plus that new chunk delta, or reverse chunk delta, I should say. Right? And I'm just interested now to know, right, because when we do the pack entity into world, it's going to have that same P from the P value that came in here. Oh. But this should be chunk P, shouldn't it? So that kind of still was a bug, because we're packing it into at that chunk P. Let me double check that. Still busted, so no harm done. How is that code working anyway? Let me take a look here. It doesn't use, okay, yeah, so it doesn't use the offset, so that's fine. Okay, so I want to enable this test. I basically want to say, hey, when I do this when I do this subtraction, how is sim region an undeclared identifier? I guess I called it region in one place and sim region in another. Not sure why. So what I want to do here is after this, I want to do an assertion on the entity P dot x equaling the test P dot x. And I want to see if this fires. And I guess honestly, I don't really need to check the x and the y, because z is all I'm really caring about right now. And so I want to see what happens here. So let's take a look at and sorry, that's not quite what I wanted. Hold on one second. What I actually wanted was to save what it was before we did the mapping, and then to check that mapping like this. Okay. That's what I actually wanted. You know what? Unfortunately, I'm gonna have to stop and restart, but we don't have the bug reproing. So you know what I can do? What I might do is inside Win32 Handmade, since we have that recording saved, I'm gonna go ahead and just play it back, right? So at startup, where does that stuff work? It's been so long since we implemented that. We never did a thing that actually allows the replays to go, right? Went through to get input file location. File and just create file, create always, so it clears it out here. Potentially. Well, no, because it wouldn't create it if it already existed, so that's okay. It wouldn't clobber it, presumably. So then we get the max size, create a mapping, and reshow the memory block. So what I'm going to do is I'm just going to start here. I'm going to take that loop edit, which is this one, and I'm just going to duplicate them. Just so I have a copy in case we mess it up, right? So I've got this copy here. If that makes sense. And then what I want to know, I guess, is when I push the L key, which is here, can I just make it so that we start playing one? Instead of begin recording, we just do begin input playback state 1, right? And maybe I just make this be if it's shift. So maybe I'll say something like, if input playing index is 0, and we kind of need a little bit more logic in here. We could actually hook this up to our debug and make some buttons for it, which would probably be what we would want, right? But what I would like to do here is just say like, oh, okay, if maybe the shift key is down, which I think we could do pretty easily, right? Because I feel like we probably would have shift. Did we ever do that? We have alt key was down. We never did shift, I guess. Let's put alt key was down up here for now. And so now we'll just do if alt L is pushed, off we go, right? So if alt key was down, this is just my little back door for now. We will do begin input playback of state 1. That was underwhelming. Why did that not work? It definitely is playing it back. So the question is, do we erase? Let's take a look. No, we don't erase, right? That's the same file. And that's the same file. Oh no, I selected the wrong one? I selected the wrong one. I'm an idiot. All right, well. That is a feature we should actually implement because it's very useful, right? It looks like I copied the wrong one. Now, that doesn't explain why this doesn't work, but I suspect it's because we clear on startup, and I don't currently preserve old replay buffers, which we would want to do, right? It looks like in here, get input file location should be fine, right? And it's going to be the same every time. The file handle, generic read write, I don't feel like it would clobber the file. When we create the mapping and map view of file, I feel like it should just be the file, right? It feels like that should have worked, because I don't think we delete them, if that makes sense. So I'm kind of curious as to why that doesn't work. Let's blow these away for now. So if I am to do something here, I'll do L and L again. So now we clearly are in a loop, right? And I can unloop us, and now we're out of the loop. And so now Alt-L should play that back, right? Yes. So the problem is on startup, we must be clearing those somehow, right? Because if I instead start up fresh and put Alt-L, now it works. So I guess I must just not have hit Alt-L. Oh. It's in the Win32 platform layer. That doesn't live reload. So we now have the ability. We did it right. It's just you can't patch the Win32 layer at runtime. We probably should have done that. But what can you do? All right, so that's fine. I'm OK with that. It's not a hard bug to repro. Let's go ahead and re-enable the hopping so I can hop Mr. Hoppy over there. Right. So I'm going to go to Handmade World Mode, and I'm going to go down to where we have the head hopper, Mr. Head Hopper. Oops, there we go. And I totally forget what we were even doing here. So yeah, I was doing in here body movement mode. We do is equal for traversables, and that should allow the hero to hop around, right? But the hero's not hopping at the moment at all. So I must have disabled something. I just don't remember what I disabled. It's been a long day. So in here, when all this stuff looks right, and the hero body stuff is still correct, right? And it moves. All of that looks okay. So, all right, so tell me why I can't hop. Yeah, that's true. We did exceed the maximum velocity. But I want to know why I can't hop. So thank you for actually generating that breakpoint, because now I can go in here and actually find out. Where are we? Let's see. Hero head. So I am going to say, let's go to here, on hero, and let's continue running. No, just do set next statement and go. So let's see. I'm going to go ahead and look in here and see what happens when we pick the closest traversable. Presumably it is not equal to, oh, it is. It does think it's equal. Oh, right. That's what I disabled. Body P. Okay. Let's try that again. Getting old. So yeah, that's right. I was just looking at body P here. All right, so let's go ahead and hop on to this little dude. Yeah. So unfortunately, that was not as nice and pronounced as the other bug was. So try that. You know, and the more I'm thinking about this, it's got to be the camera motion too, because without the camera motion, it doesn't happen. Like that point doesn't wig out at all. And in fact, that is why he's jumping off even, is because it's wigging out when the camera moves with him. So it is only when the camera moves that this is relevant. Which again really suggests the packing. So I guess we're way over time, so I'm gonna have to call it here. But we pretty much know exactly what our culprit is. We just have to debug to find the specific cause. But the packing is definitely the problem, because if you're not on there to move the camera, which is the only thing that can actually affect the simulation region origin, you can't get that to happen, right? So something about the way this is working is not correct. Something about it. And we know that the entity is mapped into that space. It has a residual offset on it. So we actually already know as well, in fact, this chunk delta thing is not even really how we would normally compute that, right? What we actually want is to say, well, this already has the residual in it now, right? So entity P, that offset is actually the value that we want to know versus the old entity P, right? So in other words, wherever the dude was before, versus where you're telling me he is now, right, is the amount we have to move all of his positional information. If that makes sense. Because basically I want to take him from this value to this value. So this is really not necessary in any particular situation. Sorry, I'm obsessing about this a little bit. So let's see, test P, old entity P. So now we can kind of look at this, or except I'm totally off here. Reverse chunk delta, pack entity into world, chunk P. Well, actually, you know what? I want to debug this first. So I'm gonna take this part here and nerf it for a second while I work on this, because this should wig out until I get it proper. Yeah, like I said. So when I do, let's see, let me just look at what chunk delta is actually used for. So it's only used for entity P+. So if I want to, I don't know why there's a negative there. That's probably the problem. Yeah, so that's the known stable value. So the question is, does that procedure cause the problem? Yeah. So we still have the same problem of it doing that crazy delta. So we have two independent methods that both produce the same thing, which is a good thing, right? Because I can verify that this is actually, that I'm doing what I think I'm doing, but I'm still getting the problem. So there's something going on here with when the camera moves, the pack-unpack is not proper. I hate to leave it for the weekend, but I mean, I think this is going to require us to dig in and actually go verify a bunch of stuff. So I don't know. I mean, I guess it's something that all of you can go solve over the weekend if you want to. So that's kind of interesting. But it's one of those things that's going to drive me nuts. What to do? What to do? I'll look at it a little more. I don't have to go right away. So I could look at it a little longer. So re-enabling this is just a test to verify, that when I pack and unpack immediately, I get the same thing, right? And those asserts aren't firing. So always in the moment, the pack works okay, which kind of suggests to me that it's the fact that when the camera changes, we don't unpack to the same place. Like the camera itself's region information is somehow busted. Which, I don't know, maybe implies this code is not correct. Here we are grabbing out the world chunks, right? And when we grab out the world chunks, I suppose, you know, one thing we could do is assert that the world chunks are what we think they are, right? So we could, like, assert, if we get a chunk, we could obviously add some assertions in here that just say, hey, we got the right chunk, right? So, you know, chunk if you look at what this code does, it's got x, y, and z in there, right? So I could assert that the chunk x equals the chunk x, chunk y and chunk z all equal each other, just to make sure that we don't have some weird thing with our hash table or something, which seems really unlikely, but, you know, if you don't know what the bug is, then obviously none of it seems likely, so you might as well check everything. So that does not appear likely. And so then when we come through here, we create a chunk position that's at the center of that. We look to see what the chunk delta is going to be from wherever the simulation origin is to the position of the chunk. And that's how we're going to displace everyone, which seems right, right? I'm at the, you know, there's the origin is the origin of the spatial coordinate system, obviously. So I need to figure out how to move somebody away from that, right? So that seems right. I loop through all the entities. I test them with the simspace p, but then I come in here to do that add entity call where I pass the chunk delta. And when I pass that chunk delta, that's just something that gets added directly. So here it is, the p-value, I add in that chunk delta, and off I go, right? Really not complicated, so I'm not sure why that would be a problem. Yeah, I don't have a lot of ideas on that. So when I'm moving the entities out, and then I'm moving them back in, I guess the first, and well, I guess the other thing that's kind of weird is we know this doesn't happen, I guess, if in other directions either, right? Or does it? I guess we don't really know, because we aren't walking across other screens at the moment. Right, so it doesn't look like we're getting that kind of crazy displacement here at all. I can reach out over there and, you know, I don't get, when the camera does do its transition, I don't get any issues there that I can perceive anyway. So it's only Z that appears to be problematic. So it has to be moving camera, has to be Z, and you can see that when the flicker happens, it is when it changes to the other sim region, because you can see that band, right? The yellow band that signifies the sim region inner apron, you can see it flashing to the lower one. So we've got this dead to rights in terms of what's going on. It's really just a question of what did we screw up in the math? And why is it only on Z? Which is also kind of weird, right? Because we've got the same code substantively. We haven't really compressed it down quite yet, but we've got substantively the same code happening in both cases. And it's not clear why we would get a situation where one of them is significantly different. I suppose another thing we could do, just for some additional information, is while we're in Crazy Land, I could go into the camera and make it be not room-based anymore. And now let's see what happens. Well, that's just a minuscule amount, so that's not very helpful. That's just an epsilon problem, probably. Although I suppose maybe an epsilon... No, that looks like a really big jump. I was going to say maybe an epsilon problem is enough, but I don't know. Okay, so we have a pretty clear answer there, right? Like, look at that. Although, you know what's kind of weird about that, too? Is that is a tremendous amount of visual Z offset for hardly any actual Z offset, right? I guess we're only seeing the camera. We need to add the camera in here as well, right? When we do the sim region, I want to see what the camera actually is. So during begin sim, because the camera must be constantly moving down, is basically what must be happening in that case. So the sim region origin in this case, I guess I'll just say origin.x or something. .chunkx. And I guess I'll just output these as debug values. And then I'll also output the offset, which should be always 0. So here's some information for us. Here's the sim region, origin, the chunk portions, right? And I'm going to go ahead and switch us to the non-room based camera, right? Oh man. All right. Well, let's go here. So you can see what's happening there, right? We're super levering downward that chunk. Oh. Wait a minute. Is this even a bug? This isn't even a bug. I can't believe I just spent that long on something that isn't even a bug. That's actually just what I threw in at the end of the day, the other day for testing, which is totally bogus. Oh my god. If I'm right about this, that is so sad. So sad. So remember we threw in the stupid floaty thingy that you stand on? Well, that thing is just hard-coded. Where'd he go? That's not him. Here he is. That thing's just hard-coded to set the Z. So it's just going to set the Z always down to whatever it's going to set it to. And if the camera moves down, it's going to just move down. Because this is not actually moving by any legal method, right? It's not actually doing any actual motion. Oh, that's horrible. That's horrible. Horrible. That's absolutely awful. Oh. Oh. I'm going to put an allochem on top of an allochem for that one. All right, so you guys see what was happening there? That's awful. Well, I'm glad we stuck around to find it, because that would not be one that was worth saving for the weekend. And it does bring up a problem with our system that we would probably want to think about. So it's not like it's the worst thing in the world, but that's pretty dumb. All right, so the problem here is just that, hey, we've got a relative coordinate system. So you've got the camera and people are in it, right? And they move around in it and they're like, okay, I moved to here. And so then later on, we just pack them back and say, oh, well, however far you were away from that origin is fine. And so then later, it's not a big deal, because when we have like the camera, for example, and I should draw this a little bit better. So let's do it across 2 frames. So here's frame 1, right? And here's where this world chunk is on frame 1. And I record where this guy is in that chunk, right? And then later on frame 2, if the camera moves this way, right? That slides this chunk over, and that's fine because it still reconstructs its position and everything's good, right? The problem is if this x coordinate, right, is always measured from the center of the simulation region. So when I unpack him out of the chunk, I put him there, right? But that floaty thing was just straight setting of where it wanted to be. And so it was assigned in screen space. So if the camera moved, it just kept being lower, because it's like, hey, I'm always at -1. So when the camera moved down -1, it was like, where are you now? It should have been 0. It's like, no, I'm still -1, right? So no matter how far down the camera moved, that stupid thing was always like, I'm further down than you. I'm still further down, right? It's like something that always says it's on the left of the screen, and no matter how far you move the camera that way, it still says I'm on the left of the screen, and so you just chase it all the way and you never get anywhere, right? And so the reason I say that brings up an interesting problem with the way that we're doing the system is, I guess if we wanted something to kind of float up and down, it brings up kind of an interesting question, which is, it seems like we want to be able to specify offsets separate from that are going to be packed properly. Like, we might want to be able to specify an absolute sine wave, right? That's something we might want to do. Now, in the meantime, we can always just say, like, oh, well, we can just do this as some kind of a delta, right? And so we can just say, like, oh, it's going to be not an absolute position or something like this. So we can sort of get around it by using controllers that don't work that way. And I'll say what the trick is that I just did in a minute there, because it might be not obvious why that works. But now if I kind of come up onto this dude here, we shouldn't ever have this problem anymore. Even if I make this guy pretty wonky, it should still work. Yeah. So that's more what we're looking at here, right? And let me go ahead and trying to think of how I might want to do this. So I probably want this to be cosine, actually, so it doesn't start out with a bias. Let's go ahead here. And I guess we probably want it a little bit more, huh? Let's give it a big old swing. I can't believe that was the bug. That's absurd. All right. And yeah, so what I did there, right, is the reason, one of the interesting things about sine and cosine, we haven't really talked about it too much on the series, but one of the interesting things about them as functions, right, is that sine and cosine are their own derivatives, right? So this is just sort of the nature of that unit circle. If I start off here, right, my sine value of this is 0, right, and my cosine value of this is 1, right? If I go, along here and I go up to here, let's say, right, then I've got a sine value of 1 and a cosine value of 0, and so on and so forth, right? Well, let's suppose, and we can just keep filling it out. So here's cosine of -1, here's sine, oops, sorry. sine value of 0, cosine value of -1. And then down here we have cosine, sine value of -1, cosine value of 0. Well, what happens if we actually plot these as vectors, right? Because I've got, if I could think of these as vectors, I've got a vector pointing this direction, a vector pointing that direction, a vector pointing this direction, and a vector pointing that direction, right? Well, those vectors smoothly go around the circle, right, the whole time. And so at any time, that vector is essentially tangent to the circle. Well, if I wanted the perpendicular, right, which would be the acceleration along the circle at that point, right? I'm accelerating in this direction. If I wanted to accelerate around the circle and find what was essentially something that goes in plane of the circle rather than sort of extending out from it. If I wanted that, right, we know what that would be. It's just the perp, right? We know it's the perpendicular operator of this vector, right, that's going around the circle. And we know what the perpendicular vector is, of something is, right? If we have a perpendicular of xy, then it's just going to be equal to y negative x, right? Or depending on which one we want to do, negative y x, right? We can have it pointing, we can do the perpendicular clockwise or counterclockwise, depending on which one we want to do. Well, if that's the case, right, then if my vector is sine, or in this case is cosine sine or something like this, right, the derivative of that, or sorry, not the derivative I shouldn't say, but we haven't quite gotten there yet. The direction sort of that on the outside is just going to be, negative sine cosine or something, right? It's just going to be depending on which direction I want to go. And in this case, it would be, let's see which one it is. So I want it to be going up, right? So cosine should be going positive, which it is, and sine should be going backwards, and negative is, right? So this is the one for going counterclockwise around the circle, right? So hey, if I want to know how I would accelerate a point such that it goes around a circle, if I know the function for putting me on the circle happens to be sine cosine, I know the acceleration that moved me around the circle was drew it wrong again, was cosine sine, which is the point that travels around the circle. I know that negative sine cosine, right, is that acceleration around the circle. Now, this is just a long sort of geometric way of looking at the fact that if you ever just look up in a book, you will see something that says, if you have a function of theta and that equals cosine of theta, then the first derivative of that equals negative sine of theta, right? And the same is true if you have a function of sine theta, right? The derivative of it is cosine. Well, that's why geometrically, right? That's the geometric reason for why, is because, hey, it's still just a circle, right? Because you can think of cosine sine as just a vector pointing out, that comes out to the circle that just goes around. Well, if you wanted to figure out what the acceleration was, the velocity was all around, right? You just do the same thing, right? You still want a vector that moves around. You just want to start it pointing upward instead of pointing outward. So you're just taking it and rotating that vector 90 degrees, and off you go, right? Which is the perpendicular. And hey, that's exactly what we end up seeing when you do it, knowing if you knew what the derivative was ahead of time. So all I did was I was like, oh, I want this thing to be based on something that isn't absolute so I can shove it into our system. And so all I did was I just said, oh, okay, just take the value and make it be less, and then just use that as an acceleration, right? A velocity, right? I didn't actually use it as acceleration. I'm not incrementing to the dz here. I'm just using it as a velocity directly, right? But again, it would be the same for acceleration because no matter how many times you take the derivative, it still gives you the same results, right? They are their own derivatives. So it's like if I start out with cosine theta and I'm like, that's my position, then when I take the derivative of that, right, I get negative sine theta. If I take the derivative of it again, it's exactly the same thing, right? Negative cosine theta, because we already know the derivative of sine is cosine. So I can keep going and going and going, right? But the position, the velocity, the acceleration of the acceleration, and blah, 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 right? It's always going to be cosine, negative cosine, sine, cosine, negative sine, right? It's just going to be that repeating all the way down, no matter how many times I take the derivative over and 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 over again, right? And if pseudonym 73 is on the channel, he'd probably talk to you about something like e to the I theta or something like this, or how these things map to complex numbers. But I'll be honest with you, that stuff is so not in my wheelhouse, I'm not even going to try. But point being, math is fun. Let's go shopping. All right, so that's it. That's it. That's all I have to say. Really. So let's go to the Q&A. Clemensbaum. Wow, that is not an on-topic question. Is there a geometric explanation for the quaternion sandwich product? Where does the formula Q times P times conjugate Q come from? So I guess I could tell you where it comes from algebraically, but I guess, to be honest, I've never thought of where it comes from geometrically. You should have asked me 15 years ago, and I probably could have told you. Well, not told you, but I probably could have figured it out. I'll tell you what. Hold that thought for a second, and let me answer Mr. Fourth Dimension's question, because that's actually on topic. I'm a bit unclear on why the relative positioning of Z worked. Is Z rebased somewhere in the code? Actually, everything is rebased, right? So everything works properly position-wise. The only thing is that you have to actually treat positions that come through. Well, okay, I can explain it much more simply, really. The only reason this code didn't work is because that, right? No amount of rebasing is going to help you if you clobber the rebased value with a new value. And that's what we did here, right? So whenever we're outputting values, we can't just treat them like they're the same as they were last frame, because they might be different. Now, they're not different in terms of what they mean, but they're different in terms of their numeric value because they might be based on a different starting point. All the rest of our code works because it's all based on values that get rebased. Everything is in terms of values that get rebased in this code. This and this both get rebased. So we don't have to worry about cold setting entity P to something, because when we cold set entity P to something, we're setting it to a function that's in terms of other rebased values. Here, there is no rebased value on the right-hand side of this equation. So we just clobber a rebased value with a non-rebased value, and havoc ensues. Zaxi, I'm still quite newbie on programming, but wouldn't commenting your code a bit more help in situations like today? I mean, I'd say the obvious. I'd say the opposite. I would say if you watch what just happened on the stream, no amount of comments could have possibly helped me. And the reason for that is because the line of code was something we added on a previous day that is not even in the region where we were reading. So we would never, even if we had a comment in here like, this is fucked, like let's say we knew, oop, I'm not allowed to swear on screen. This is bad. Let's say. So even if we had a comment that was like, this is bad, we would, those of you who've heard me talk normally, I swear continuously. So how we have gotten away with, I think, only 3 swears on Handmade Hero so far is beyond me. But I wanted to try and keep it relatively clean for children. Anyway, so basically what happens is, even if we had a comment in here that even if we knew, which I didn't know when I was writing it, I didn't even think about that. Otherwise, I wouldn't have written it in the first place. So even if somehow I'd known, even then, if I'd added a comment that was like, hey, by the way, don't do this, we never looked at this code. So there's basically like, and this is true of basically all of the things that I've found in my life regarding comments, which is that comments are really only useful when you're completely done. Like basically when you're completely done with the code and you're wrapping it up, right? You need to go and write a comment that's like, here's how this worked. Because later when you go back, you're gonna have to read that comment and go, okay, and I get it. Anything else that you comment on is just you're wasting your time. Because you're not gonna read the comment's gonna get out of date. And then if you start trusting the comments, they're probably wrong because you probably changed something and forgot to change the comment. So I say never comment till you're done with a section, and then put a comment at the top of that section that's like, hey, here is a good description of how this algorithm and code and stuff is supposed to work. Because later when you come back, you need to do that. And Cuber Caleb, yeah, I think it was only 3 swears. Not in the pre-stream, because the pre-stream's fine. But in the regular stream, I thought we only had 3. If you can find more than 3, let me know. I thought this would have been swear number 4, I think. I think there were 3 previous ones. I don't know. Can't quite remember. Long Boolean. So not only did that bug affect the floating thing going to high-low, but it also was the cause of the head picking the wrong point and the body jumping to it. Yes, so what was happening there, right, is that when that point got, well, let me just draw it for you. So here's what was happening. Let's view this from the side. Okay. Here's the hero. They're standing on a point. Here's the head. Here's another point next to him. Here's another point next to him, right? And this is the point right now that we're on. Here's the 0 line, let's say. This is not actually quite right. It's not the exact, wasn't quite at the 0 line where these points were. It's a different location, but that doesn't matter for now. And this point's getting displaced downwards by that z equals sine theta function, right? So here's what happens. Now, on the next frame, okay, everything's rebased properly, so we're looking at the exact same situation, but this fellow, right, now we sort of have a change in where the camera is. So the camera now comes down to here, all right? These guys are still at the 0 line, and that's fine because they all get displaced properly, so their relative positions are like this. So does the hero, so he's in the right place. But this guy, right, even though he gets he gets rebased, so his P's in the right place, he then clobbers his P with this displacement again, which drops this point down to here, right? So it was here, now all of a sudden, instantaneously it's there. Now we ask, what's the closest point to here? Well, it's not this one anymore, it's this one. And snap, that causes the guy to jump, right? So it's very, very straightforward, but, you know, until you actually find the bug, it's always like, what? So. The mind overall. What if you really wanted to set an absolute position for entity? How would you handle that? Well, it's actually not hard because we have the chunk mapping system. So if you want to store an absolute position, you can just store an absolute position with one of these world offsets, right? You can just put one of these, store actually one of these, and then every time you just call map, and then you get it out, right? You call map into SimSpace or whatever. So it's not actually hard to do, it's just that's not what we were doing. So. All right, so it looks like we don't have questions, so I'll try to think about Clemensbaum's question. This is not a question which anyone on the stream probably would have any idea what I'm talking about because we've never covered quaternions on Handmade Hero to the best of my knowledge. And it's been so long that it's really, I have not really done anything with quaternions in probably like seriously 10 years, probably more like 12 at this point. So I don't think I'm probably going to be very helpful, but So the question was, and Clemens, correct me if I'm wrong, but the question was, where does the sandwich, you called it a sandwich product. And the sandwich product, you're talking about like Q, P, Q inverse, right? And what this is here is like, these are quaternions. And this is technically also a quaternion in some sense, but oftentimes when people are talking about this, this is actually a vector that's been extended into a quaternion. And is this basically the core of your question? Like, tell me, I'm going to wait for the chat a little bit here. Tell me if this is what you were talking about. Okay, so Clemens Baum confirms that that is the question. All right, so I'm trying to think about how to illustrate this. So I'm going to start with the algebraic way to think about it, and then I'll try to come up with a geometric one. Now, you may already know the algebraic reason for this, and if it is and if you know the algebraic reason for it already, then I apologize, but I'm going to have to work through it because, like I said, it's been so long since I've worked with these that I can't just pull it out of my head at this point. So the algebraic reason for this is I'm assuming, again, like I assume you already know this, but I'm just going to say it anyway. So this is actually the similarity transform. I've never heard it called the sandwich product. But essentially this is not specific to quaternions, right? It's not really a quaternion thing. It's just a spatial. It's a frame of reference thing, and you'll see it in everywhere. It exists even if if you went and looked into like the tensor math or gravitation and stuff, you would see the same stuff happening. It's not specific to quaternions in any particular way, right? I guess is what I want to say. So you could think of this as also having to do with matrices. So if I had a matrix B and I did this equation to it, okay? Totally separate from quaternions, just straight up matrices. The same intuitive process is happening in both cases. In both cases, it's called a similarity transform, again, as far as I know. In either case, it's called a similarity transform, and in both cases, it means the same thing. And what it means is, tell me the meaning of thing B in the space of thing A. And so in quaternions, if I was to do these the same, right, I would say there's the B quaternion and the A quaternion, right? And here is what it is, right? It's the ABBA transform. It's the dancing queen. So, so first off, I'd look this up. Right? I'd say if my explanation doesn't help you at all, which, like I said, because I'm so rusty, it probably won't, you can do a lot of reading on the similarity transform, and somebody out there is going to have an explanation that resonates with you, I would suspect. So if you were looking for sandwich product, maybe that didn't help, but similarity transform, I think, should. I would be shocked if you couldn't find a good explanation on similarity transforms because they're ubiquitous, they're everywhere, and they're very important. Okay, so where does the similarity transform actually come from? Now, here's the thing is, I could have told you this. This would have been second nature to me, while I'm going to have to stumble through it a little bit here. So in order to do a similarity transform on something, it helps to think about it in terms of what this thing might be transforming. So I'll try again, because it's supposed to be an intuitive explanation here. Let's talk about these things as not as matrices or quaternions, but as things that represent a frame of reference, all right? And so if I have a frame of reference that's out in the world, so let's suppose this is an x coordinate and this is a y coordinate. And it doesn't matter whether we're in 2D or 3D, so I'll just draw these as 2D, that this works in any dimension. This is not, again, this is matrix math. It's not dimensional. It doesn't care how many dimensions these things have. So 2D, 3D, 1D, whatever, it doesn't matter. So if I have something and I have an interpretation in that space, right? So here's my point, and here's my x and my y frame, and I'm talking about maybe an origin even, and I'm talking about this representation here. And what I'm going to do is I'm going to say that I want the orientation to be the only part that I care about. Because again, since this is a general matrix thing, we don't have to care about positions in any particular way. We can just say rotations, and if it works rotations, it works, right? So if there was some canonical coordinate system, great, but I'm talking about this specific coordinate system here, and I'm going to call this coordinate system B. And here is P, and this P is being expressed, let's say, well, I won't even talk about where it's being expressed yet. I'll just simply say that I have this coordinate system B, right? So I could create an equation where I said, assuming that B is expressed in the outer canonical coordinate system, so this frame ref, the screen, if you will, what the screen is right now. I've got this slightly tilted thing, and then I've got the actual screen coordinate system, which is here, right? Well, if I wanted to talk about where P was on the screen in the canonical coordinate system, right, then I would have the equation P on the screen, right, equals P times this thing. Because P is in B's space here, right? This is, you could almost think of it as P in B space, right? P is in the space of B, so in order to put it into the outer frame of reference, I have to multiply it by that matrix, or rather, if we get out of the matrix language, just talk about frame reference, I have to do whatever the interpretation is, whatever that interpretation operator. Interpret this thing in my space so that it becomes in the outer space, right? And in matrices, that's very simple. It's just matrix multiplication. We know that. We know that if we multiply a point by a matrix, we transform it by that matrix. So it's very intuitive. You've done this a million times. Everyone knows what it is if they're a 3D graphics programmer, and I'm assuming you would be because you wouldn't be asking about quaternions otherwise, right? So we know this equation, and it's very, very comfortable. And this is the equation that does that expression. It puts B out into the outer frame. And you could think of it by notating this a little further. You could say, well, I have I could eliminate the primes, and I could say, well, let's say this outer coordinate system. We'll even introduce a letter for it. The outer coordinate system is just C. Well, I could say that C, P in C space equals whatever B is encoded in C space, right, times P in B space, right? And what you can think of this doing, if you see the way I've notated this, is you can almost think of these as canceling each other out. So if I want to go from B space to C space, I need the B in C matrix, right? Because when I talk about a frame of reference, I can't talk about a frame of reference without talking about what frame of reference that is in, right? And that's the curse of programming, right? Is that generically we can talk coordinate free and everything is fine. But when we actually go to implement, right, there's what are the actual numbers, right? We're feeding in actual numbers at implementation time. So in the abstract charts, we can talk about the frame of reference B, and we don't really even have to talk about who it's encoded in. But once we start talking about the minutia of it, we have to start talking about, well, okay, what are you talking about? When you say B, when you actually encoded that, what did you encode it in? And well, we're talking now about it being encoded in C space, right? So now, let's assume that we introduce A, right? So we're going to have another thing here that's the frame that's A. Okay? So that's my A frame. Now the frame A is a different frame than the frame B, right? And I'm going to call this AC because I'm going to encode them both in the C space. So I have A in C space and I have B in C space. And this is, again, adding a lot of things. And you're like, I'm getting confused, AC space, very right. I apologize, this is just the nature of this kind of problem. But you can think of that C space, that's just the world space, right? This is effectively world space. It's just a third frame of reference that I'm encoding both A and B in. So this is exactly what you have in a normal program. In a 3D program, you have a 3D matrix A, a 3D matrix B. They're both encoded in world space, right? and I'm talking about the two of these matrices in world space, let's say, right? So that's all I'm talking about here. I've got three spaces, an A and a B, and then there's a C, which is the encompassing space that encompasses both of them. Okay. So now, let's say I want to ask the question, well, what if I wanted to know what B was, right, in the space of A? So I no longer want B to be encoded in the space of C. I want B to be coded in the space of A. And you can imagine this as being like a hierarchical kind of a transform, right? It's like when you do a bone system and you say like, oh, you know, the child bone and the parent bone, right? Well, the child bone is encoded in the space of the parent, and the parent is encoded in the space of the world, right? So you have C is the world, A is the parent, B is the child. I want to produce that, right? If that makes sense. Well, intuitively, we kind of know what that is. And so we could, right off the bat, perhaps jump in to writing that and saying, well, I know that if I want I know that if I want B in the space of A, then all I really have to do is make A be the new world coordinate system, essentially, right? So we know what that is, right? It's the inverse of A and C. We just take that inverse of it, which is basically doing the opposite transform, right? And then we can take anything that was in that space, and that will map it into A space, right? If that makes sense. Now, why is that doing what it's doing? And we'll sort of get into that in a second here. But you can almost think of this inversion as swapping these two, right? Essentially, what this transform becomes now is C in A's space in some sense, right? It's sort of saying, how would I get to C if I was in A, right? So that swaps what these two things mean. And again, you can read the canceling. C and C cancel, and we just get B in A's space, right? So hopefully this is helping you kind of warm up to where we're going here. But hopefully that all made pretty good sense. And obviously, like, I don't know what your level of familiarity with is, but again, like I said, I assume if you're asking about quaternions, then you're reasonably comfortable with everything I just said, and it should be like, okay, yes, like that's all stuff I've, you know, kind of done before, and even if you maybe didn't think about it exactly this way, you've thought about it, and that's relatively comfortable, right? So it's pretty easy to produce like B in A space, or I could have produced A in B space, or, you know, whatever else, right? So now let's talk about that similarity transform part of it, right? So now let's ask the question, what is this weird one that we're talking about here, right? So we're talking about something where we're like, you know, we don't know what we're getting. We're getting something that you're saying I don't really understand why it is or what it is, but I know that it's produced in this way. I know that I take, you know, these transforms that I have encoded, and I know that I'm doing that to them, right? Excuse me. I'm very, very phlegmy. Okay. So this is the similarity transform, like we said before, right? And it's going to basically be doing exactly the same sort of things as all of these operations were. So let's see if we can read it off and see what, you know, it ends up looking like. Well, first of all, like I said before, when you do this inversion operator, you're sort of doing the opposite mapping. So this is really more properly perhaps written in the way that we're doing it as C in, you know, in A space. So I have A in C space times B in C space times C in A space, right? And so if we read the cancels, right, and because remember how this worked, if I had here before what I was talking about, where if I have P in B space and B in C space, right, you can cancel the small to the large, right? And we are lining up essentially, what's the word I'm looking for? We're lining up essentially the same thing, but now this time around, we don't have the same smalls to the large, right? They have to kind of carry through, because we can't, like we had before, where we would do before, you know, A in C space, B in C space, right, or something like this, there is no cancel that happens here. This is just A, B in C space, right? It continues, it holds, if two things that were in the same thing, they kind of hold their C, right? So these two terms combined together is just going to be the AB transform in C space. So this first term, we can see exactly sort of what it is, right? And what it is the composite of these two, right? It's doing both A and B. So it's doing A first and then B, and it's like combining the two transforms in C space, right? That's what this would be, if that makes sense. And then here we just have the C in A space. So this is doing the opposite of what A was doing, right? So essentially what we could think of happening here is we can think of this as putting something that's on this side, right, into C space, then applying B to it in that space, and then reapplying A in the same space, right? So it's like undoing A, doing B, and then doing A again to put it back, right? And so what you can kind of see in this case, and I guess I probably, if I was cleverer about how I'd done this notation, this would probably actually be possible to follow through. I'm trying to think of how I would have notated that. I feel like there probably would have been a way, since I was writing these letters down just to have you be able to remember them. I feel like there probably would have been a clever way for me to do this so that you could actually cancel them out the whole way through. But I'll be honest, I don't immediately see how you would do that. Because what you want to end up with here, right, is sort of a... excuse me. The effect of B in C space, the effect of B as if it was in A space in C space. But I don't really know. Yeah, I'd have to think about that more. Is there some way to... I don't know. So I feel like if you were a tensor math person, like I feel like if you asked Pseudonym73, he'd be able to figure out how to notate this so it actually more cleanly worked out. But but sorry, I can't figure out how you would really think about crossing these in some way. So I'll have to just ignore that for now. But as I'm doing this, I don't think I've ever written it out quite this way before, so I never really thought about, hey, maybe you could make these things actually line up in some way that produced the result that you wanted. But you think you'd need one more like level of writing probably to make that happen. Anyway, okay. So what we're doing here, right, is we're moving something. Excuse me. We're moving something such that A is the space that we're now in. We're applying B, right? And then we're moving back into to that A space, right? If that makes sense. We're basically undoing that previous transform. So if you look at what happened on the diagram, what would happen on the diagram? Here's our A in C space encoded, right? We have something, if we wanted to talk about some point that we were just talking about, right? Then the first thing we're doing is we're saying, okay, if that point, let's say that point is encoded in C space, so it's actually floating in the screen. We first are going to do the inverse of it here. So we would essentially be moving so that we're in A's space. And you know what I'll do? I'll draw these out for you one step at a time. All right. So here's A encoded in C space. Here's a point also encoded in C space, right? So the first thing we do, if we wanted to do this now, and I'm going to do AC, BC, AC inverse, right, times a point equals some new point, right? And I'm just going to call it P prime because we're not talking about what it actually is yet, since that's what we're trying to discover. Okay. So here's my point in C space. Here's my frame, AC. The first thing I do is I multiply by the inverse of that frame, right? So what does that do? That takes us from this coordinate system into one where AC is the root coordinate system. So this is now AC effectively, where it was, right? Now this is just a canonical coordinate. We've undone it, so we wouldn't really necessarily even call it AC anymore, but you can see what I'm doing, right? I'm writing the AC so that it actually occurs coincident with the outer axes, right? So now we would have PC would be like here, right? Because it would maintain its relative position. We would warp it back, right? And now we know that we have BC, okay? And BC was this sort of more slight thing that was right here. Well, remember, we are still applying, and this is why I wrote these in, so I apologize if they're confusing you more, but you've got to track them somehow. Well, B is still in C's space, okay? And A is now where C was, right? In other words, we've shifted A so that is now in C, because we applied the inverse of A and C, so we basically moved into C's space, remember? Because this is now, it's the C to A transform. So we've moved into C space, so A is aligned with C, B is in that space, so we are now applying B in its normal way. We did not change B at all, we're applying it normally, right? And it's this slight tilt. So now we're going to reinterpret P in that space. Now what's that going to do? Well, it's going to move it this way, right? It's going to tilt it down a little bit, okay? So that's what happens after we apply. So we applied AC, now we applied BC, right? That was it there. Then finally, we're going to apply AC again, right? So we're going to undo what we did originally, okay? So what we do now is we move this whole thing back. We do this transform again, right? We do this transform again, which slides everything back down and moves this new point down here, right? To apply that AC back to where AC was. Okay? So, hopefully you can see what that means. We first move a point into one frame of reference, AC. We then apply the transform that we're talking about here as if it were still in the world space. We don't touch it at all. We do it exactly as it used to work. And then we apply AC again, right? So we re-move back to that space, if that makes sense. So essentially the similarity transform, what it does, this equation right here, if I have A, B, A inverse, then what that effectively gives me is it gives me B as if A were world space. Right? That's what it does. Now, you may ask the question, well, why do I care about this? Because if we now come back to this, right, and we say, well, okay, that's all great, but doesn't this point just end up basically where it would have ended up anyway, right? And the answer is, in 2D, yes, it would. And the reason why in 2D it would happen is because rotations commute in 2D, right? Rotation by an angle just adds in 2D. So no matter which order I apply these transforms in, I'm home free, right? I don't care. So what I could do is I could say that A, B, A inverse, if all I'm talking about is 2D rotations, well, that doesn't matter. It's just the same as A inverse B, which is the same as B. And you're right. The problem is that doesn't happen in 3D. In 3D, rotations do not commute, right? Because they are non-Euclidean in that way. They do not obey any sort of rearrangement. You can't start swapping the terms and expect the 3D rotations to come out being the same. And furthermore, this would not necessarily work if these matrices represented something else. So, if they weren't rotations, if they were some other thing, maybe even in 2D, we could construct something that wouldn't work because the matrices, wouldn't work properly. They don't commute, let's say, because matrix multiplication in general is not commutative. It just happens to be in the case of a 2D rotation. So, normally, there are actually two different things that would happen here. One would be if you applied B, and it would be a certain rotation, and another one would be if you applied A, B, A inverse, right? And they're not actually the same. This one applies B as if we were in A's frame. The other one applies B as it exists in the world normally, right? And so another way of saying that would be it applies B as if the world had already shifted so that A was where it was, right? But it doesn't apply it in A's space. We still end up with a world space result. And that's why, right, because we were talking before about like A inverse B or some like parented transform. Those are ones that cascade and take something from the child, from B space, right? If we had B in here or something like that, where we're trying to take something from B space all the way out to world space, will be multiplied by B and A and whatever, and they're parented, that's one thing. But in this case, we're talking about everything's in world space. A's in world space, B's in world space, the point's in world space. And now I just want to know what's the transform that applies B as if it were in A's space, without actually ever putting it there, right? If that makes sense. So, let me keep going. Hopefully some of this is helping at all. Maybe it's all complete hogwash. I don't know. But like I said, it's been so long since I've worked on this stuff. It's a shock I'm remembering any of this. So my explanations are probably not as lucid as they would be if that wasn't the case. But, so continuing on, think about this algebraically, right? So let's say I have P prime equals BP. Okay, this is saying, all right, and I'm going to use that notation again. I apologize again if it's confusing, but let's say B is in C space and P is in B space, right? So this is essentially the case where I have a point encoded, and this, we could think about this as like a bones kind of a system or something like that, right? Where let's say I've got a mechanical arm kind of a thing here, right? And here is my transform for B, okay? And I'm representing it in this outer space C. And this is a point that's encoded off of B, that's P. And I want to know in C space what this is, right? So I'm going to multiply P in B space times B in C space, and I get P, the world P, okay? Now I want to have this be a two-link thing. So I'm going to consider this, right, which is the A transform, and B is going to be in A's space. So we're not dealing with that anymore. Instead, we're going to deal with a parent-child situation. Now, we all know how to get that, right? If I want P in C space again, well, now I've got to concatenate all the transforms the whole way around, right? I've got A in C space, I have B in A space, I have P in B space, right? B's cancels, A cancels, I end up with P in C space. And that's how I transform it out, right? So you've seen that before. Yeah, you've seen it like a bunch of times, right? Now, what would happen, however, if I wanted to do this transform, the same, like I want to do, I'm trying to think of how to explain this in a way that makes more sense. Okay, so now let's say I want to do this same transform, exact same transform, but I want to encode P in a different space, right? I want to encode P in, I want to encode P as if it were in, sorry, bear with me for a moment. I'm trying to think of what the best way to explain this is. I'll start with this. So let's suppose that I was going to move P to a different space, right? I'm just going to move P to a different space entirely. Well, it's free for me to take this equation and insert any pair of a matrix and its inverse, because a matrix times its inverse is the identity matrix. So we always can do this, right, if I want to. So I can insert the identity matrix here into this equation, algebraically, and it doesn't change the meaning of it, right? I could insert 50 of them and it wouldn't change meaning because the identity matrix doesn't do anything. That's the point of it. That's why it's called the identity matrix. It's the multiplicative identity, just to be clear, not the additive identity, which would be all zeros. So multiplicative identity matrix, I. Diagonal, one's down the diagonal, right? So if I replace this identity matrix with this combination, A, C, A, or actually I'll do the opposite one because it'll be easier for me. A inverse AC, PB. Right? Then now you can sort of see one place where I might naturally get the similarity transform to occur, right? Which is if I wanted to apply the composite transform of A and B, right? but I have my points in the space that's been transformed by A already, right? So let's say I want to store all of my P points. I want to store them pre-transformed by A for some reason, right? But I want to know when I store my other matrices, I want to know what the transform is that would give me back what I was doing before, right? That's one place where this tends to happen. And so you can imagine something where you have, like I've got P and I've got A, B, P, right? And oftentimes you'll get a situation where you go like, oh, okay, let me go ahead and add in that identity here, right? A inverse A, P, right? And now I can press this down to like similarity transformed point, right? So here's my similarity transform, here's my new point, whatever you want to call it. And I keep this and I keep this, right? And later I can reproduce P prime, but with a different A space, if that makes sense. Maybe it does, maybe it doesn't, I don't know. To give a concrete example of that happening algebraically, let's talk about space change. Okay. Yes. This might make some sense too. I don't know if any of that made sense to you at all. Hopefully it did. Like I said, I'm sorry. It's all really buried back in the brain, so I don't remember like good ways to communicate it as well as I should. So one more time, coming at it from a different angle, see if this helps at all. Let's suppose that I have that bone chain, and now I want to transform the bone chain, right? Artist creates a thing in Maya, right? And the thing looks like this. Okay, here's the root A, here's B, here's C, and here's the point. Okay. So we know that this is some animated thing, right? So this is a dude's arm or something, right? Here's like the center point, here's the shoulder, here's the elbow, and here's the hand, right? So this is a bone system, and I've got an animation. So I've got animations and all this stuff. I've got each of these is like an animation, right? Track that I've got. And I've got points which define the skeleton, right? So they're around here or whatever. Okay? So I know that in the tool, in the art tool, my equation was always this, right? It was take a point, multiply it by C, then B, then A, and then I get my transform point out, right? And I'm like, that's how I was doing everything. It's all good, and I know that I can just work with it, and it's fine. But let's say these have scale and shear and position and everything else in them, so they're completely generic transforms, right? Not just rotations. So everything goes in here too. All right. Now we say, well, all of these models were modeled a bit wrong, right? We actually didn't want them modeled with Z going up. We wanted them modeled with Y going up, but Maya had Z going up. And they're also modeled like 45 degrees twisted or something, right? So we've actually got this other matrix M that we want to apply to the mesh, right? To all the points, to sort of move them to the right locations, right? That's what we wanted to do. I should also mention, well, I'll leave this out for now. So what I effectively want to do here, right, is I want to be able to store, I don't want to do this at runtime, meaning I don't want to have to do extra matrix multiplications at runtime. So the trivial way to make this happen, right, would I just be like, oh, okay, well, if I want to make all of this thing transform by M, I just stick an M on the end. I'll just transform everything by M, right? And I'll be done. But if I was to do that, right, I would have to actually do that extra matrix multiplication, right? There's no real way for me to get around that in any particular way. Is that true? Well, I guess I'm trying to construct a scheme where I totally have to use this. Because I suppose you could just bake it into this track if you wanted to, right? You could bake that transform in here, which still kind of works. I guess you'll have to just assume that for some reason you want to do this. You want to store the p's pre-transformed by m, and you want to store these pre-transformed by m, so it really all is in that space. And by the way, we did this in Granny because people on the export path want to be able to do this, right? They want to be able to bake their assets into whatever coordinate space they want. They don't want to have to transform it at runtime, right? So it is a real case. I'm just trying to motivate why you would necessarily want to do this. And simplicity is one. There's probably other real reasons you want to do it too. But so what I want to do, right, is I want to transform the p's by m, and I want to transform all the matrices by m, but obviously I can't just stick an m on the beginning because that would just transform all the ma's. The p's would not actually be changed in the way that they should be, and none of these would be changed the way that they should be either. And so you kind of end up in this situation where you're like, huh, right? So if I actually want to do this though, right? What I want now is I want to have my m, this is what I want. So I do want this. So if I multiplied both sides by mp, I get the right equation. This does produce the results. I just can't store it still as three matrices and the point because it's got this extra transform in there, right? So the question is, what can I do to get around that? Well, let's use that trick I said about inserting the identity again, right? Everywhere. Okay? Well, if I insert the identity in between each of my terms, then I can expand that identity out, if I want to m inverse m, right? So everywhere I had an I, right, here it can come that, here it can become that, there's my C, and here it can become that again. So everywhere I have an m, an I can expand it to an m inverse m, right? Well, now look what I got. Well, similarity transformed A becomes the new A. Similarity transformed B becomes the new B. Similarity transformed C becomes the new C. And the transformed point becomes the new input point, right? This, I don't know what we want to call this new. We don't really want it to the n. Give me some other name for it. This is A new. I don't know why. B new, C new, and P new. Right? Oh, and I guess I could call them the emified. Call them emified. All right. Algebraically, hopefully that makes reasonable sense to you because nothing weird happened there, right? All I did was say I'm going to multiply this equation on both sides by m. So I'm just transforming the space by m. That's it. I just moved the points by m. That's all I did, right? So geometrically, right, whatever we had, I don't know what it was, right? Here's that p. Whatever we did, we just moved it by m. If m was some weird rotation, we just moved the point, right? That's all we did. And then we said, well, all right, insert the identities, expand those to m inverse m. You can see the similarity transform happen here, 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 and here. Here, here, and here. And you're left with the m on the p, right? So what's that doing intuitively? Well, like I said, the similarity transform applies A as if it's in M's space. So you can see what this equation actually does. It says, I want to store P in M space with the M modification, right? That's what I actually wanted to do. And in order to do that, I need each of these people to be as if they were in M space, right? And so that is essentially what is going on there. It's similarity transforms is doing that interpretation for you. So you can store those with this point pre-transform, but still get the same result, right? Still end up with MP prime at the end. So in Granny, this is what would happen if you asked for a coordinate system change, right? It would take all your animation tracks and apply the similarity transform to them, take your mesh and apply the transform to the mesh, and then you were done. So there you go. All right. So there you go. Hopefully that answered the question. So I guess I'll now ask Clemensbaum, did any of that help at all, or is it completely useless? Clemensbaum, thank you, very insightful explanation. Can you recommend a book where I can learn more about these kinds of things? How did you learn it all in such an intuitive way? I mean, the answer is how I learned it all in an intuitive way is I worked on character animation code for 5 years, right? And character animation code is the place where this stuff gets drilled into you quick, because anything that you do wrong will come back to haunt you. And licensable character animation at that, so it was being used by hundreds of studios, so every little problem that could crop up cropped up, and you have to be able to work through it. What I used for sources over that time, I don't know. I mean, I learned linear algebra out of Gilbert Strang. People have said that's not a very good book, so there's probably better books out there, I don't know. I don't really remember him covering the similarity transform, but he probably did. I don't know that I learned it from him, though. I don't think I did. I don't really know where I learned that. I really don't. Yeah, sorry. I really don't know where it's good places. Just working with matrices a lot and thinking about transforms a lot helps. With quaternions, I did a lot of the early work. There was nobody had ever worked out any of that stuff, at least not in our industry. So I was used to having to figure this stuff out on my own. Like the quaternion multi-way linear blend was a bunch of stuff that I had to do on my own. The quaternion double cover stuff for character animation, I did that on my own. So I was very used to having to work these things out myself. And so some of these things were things that I probably saw in a book. This one, I feel like I've seen this covered. This exact thing, I think. But I'll be honest, I really can't remember. I don't know if I had to work that one out on my own or not. I guarantee you this is covered somewhere. I just don't know whether I read it or whether I had to work it out on my own. I don't know. And sometimes it's something you work out on a blackboard with someone else too, you know, like maybe I was talking to somebody and we worked it out, you know, so it could have been something that I collaborated with on someone, something like that. It's not really a big aha moment necessarily, so it's not like it was something I would have remembered exactly how it came about. But yeah. I would say the number one thing too, beyond books, like books are okay for math, but a lot of books are bad at math. Like they don't explain math well. So I would say the number one thing to do, if you really want to learn this stuff and be really good at it, actually the thing to do is write a program that renders it all. I had this program I wrote called MathViz, and it was just a little thing that drew like grids and arrows and stuff. And I used to do all my experiments in that. And so I could draw everything. So I'd like draw all the frames of reference, like I could draw all these, I could draw the results of transforms and see. And it really builds up your geometric intuition when you can see everything, you know? So that's something to think about. James Woodman, would any of this have been mentioned in the comments in the Granny source code, or is it considered obvious to people working the concept? This probably is pretty obvious, but like in the Granny source code, for example, there's a thing, the sparse B-spline curve fitting solver, which was a pretty crazy thing in its day. Nowadays, I'd probably do it a lot differently, but at the time, it was kind of crazy. That thing is absurd, and there is 5 pages of comments at the top of it explaining how it works. So some things in there are documented heavily, because I'm like, this is very, very confusing what this does, right? So this, I don't know. I mean, if you're working on character animation, you probably would. I mean, you should probably know this by now. So I don't know that I would have commented this in any particular way. I might have put a comment that's like similarity transform the thing or whatever, right? And if you don't know what that is, probably you shouldn't be working on Granny. I don't know. I mean, I don't know. Like, if you don't know what a similarity transform is, it's probably not. You probably shouldn't be working on licensable character animation. But who knows? Maybe you could now because hey, it's already built for you. So but no, you're gonna get bugs and you got to work through them. So you'd have to know. I mean, you'd have to know that. I would think. All right, I'm gonna wrap it up. Oh no, Milton. I don't think I've ever seen Milton clash before. I must have done something to make it angry. Let's see if it saved our work, by the way. This will be an interesting test of Milton, because I haven't ever hit the save button. Supposedly, Milton just works. And you don't ever have to tell it to save. Let's see if that's true. Wow. That's pretty cool, man. You got to admit, that's pretty cool. Can you undo after you reload? Holy. Okay. You got to admit, that is pretty cool. Right? You just never have to hit the save button, and if the thing crashes even, you just reload it, it's there, and the undo is even there. That is so the way software should work. That's awesome. Sergey, that is very well done. Very, very well done. Oh, I said his name wrong again. It's Sergio with a... It's only Sergey on the stream, right? It's like Serge XYZ or something. But it's actually Sergio in real life, and it's the one that I couldn't pronounce sexily in Spanish. I was like, Sergio. But... All right, so I'm going to close it down. That was pretty awesome, Milton. Well done. Well done, sir. If only Photoshop worked like that. I'm sure our artists at Molly Rocket would be much happier if it did. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game. It comes with a source code. We also have a forum site you can go to if you want to ask questions. We have a Patreon page if you want to support the video series, a schedule bot that tells you when we're going to be live, and an episode guide if you want to catch up on past episodes. So check those out. I'll be back here next week. The schedule next week might be a little weird, so definitely check the tweet bot for that. Head over here if you want to know when it's going to be live. Until then, everyone have fun programming, and I will see you guys on the internet. Take it easy, everyone.